Hey guys, Roman here, quantitative researcher and trader, founder of Quant Guild. If you're looking to get into algorithmic trading, then your strategy must consider the overall regime that you are trading in. Whether that is a low, mid, or high volatility regime, whether you're considering momentum or reversion, social, attention, so on and so forth. If you do not consider these things, then all of your statistics within a back test will be incorrect, just like I discussed in my previous video. What we're going to do in this two-part series is create a live Markov chain regime switching system. And that is exactly what you are seeing here. This system is going to operate on 5-second bars. We're going to get tick data from interactive brokers. I'll leave a link in the description below if you'd like to get started with interactive brokers. I highly recommend them. I've been using them for over 10 years at this point. And what we're going to do is use them to acquire this tick data and build this system that you're seeing here, this live Markov chain regime switching model. What we're going to do is in this video build the shell so that we can effectively record this bar data. And then in the next part, we're going to talk about the Markov chain model itself, integrate it into this system, and then you'll be ready to either drop this into your own trading strategies or extend this into other regimes. I'll give you a quick demonstration of how this system works. When we run this application, we get a nice user interface here. I can connect to interactive brokers through my local host and my port. And then once I connect, I can select the equity that I would like to effectively classify the volatility regime of. So in this case, I'm going to use Apple. And as you can see here, I have the current 30-second candles for the Apple stock right here. And what we're going to do is we are going to start the stream of data for Apple and create these 5-second bars. And what we're going to do in this process is calibrate our Markov chain model to the previous 60 bars of data so we can see what the current temperature of the market is. So we can effectively classify the regime based on what the current market state is. We don't want to go too far back. Otherwise, these regimes are going to be stale. So we're going to look 60 bars back. We're operating on this short time frame. And what you're seeing here is the Markov chain model in action. So it classified the volatility emissions here as a low volatility regime, then here a high vol regime, here a mid, and then back to low and mid. And it's going to continue to operate in this capacity. And if we would like to recalibrate the model, we can just click this recalibrate button, and then all of the data from the previous 60 bars at the spot time will be used to effectively fit the Markov chain model. So this is a very cool system. We're going to head on over to VS Code and build this shell from scratch. And then in the next video, we're going to integrate the Markov chain model, and then you can drop it right into your trading systems or of course create your own regime extensions. All right, here we are in VS Code. We're going to be building this entire project from scratch without AI, just like the good old days. If you're only interested in the source code, I completely get it. I'll leave a link to the project in the description below. I'll also post it to the Quant Guild library on GitHub, where you can find the source code for all of my quant builds. In any case, I highly encourage you follow along. It certainly is the best way to learn. So we're going to go ahead and get started here with our necessary imports. I'm going to start by importing tkinter for our user interface. I'm going to say import tkinter as tk, import tkinter, or I should say from tkinter, import ttk and message box. Then I'm going to import threading so we can handle the stream of data, import time, and of course date time, so we can handle those dates that we're going to display to the user. We should probably also import the matplotlib version of dates, but we'll see if we need it later on. So we also need collections, we're going to create a queue for our bar data. I will say from collections, import dq, so that we can have this rolling set of bars. It's a fixed sized queue. I will import matplotlib.pyplot as PLT to handle the candles that we're going to display to the user in the interface. I also need a few more things to display that canvas on the tkinter user interface. I'm going to say from matplotlib.backends.backend, I think it's tkag, import figure canvas tkag. We also need to add some patches for the candles. So I'm going to say from matplotlib.patches import rectangle. Okay, that should be everything we need for the user interface and the candle chart. Now we need the imports for interactive brokers. So I will say from IBAPI.client import eClient, from IBAPI.wrapper import eWrapper, and then from IBAPI.contract import contract. The eClient is how we are going to send requests to interactive brokers, whether we're using the gateway or the trader workstation. That is how our application is going to send requests for data to the server, and then it's going to respond in the implementation of the eWrapper. Now, the contract itself is to specify the security for the data that we are streaming. So you could use a futures, you could use an option. It doesn't matter what you choose here. We're just going to be using equities for the sake of this build. So we're going to import contract. And then I will also import warnings. And then I'm just going to ignore warnings. So I'll say .filter warnings. We're going to ignore these user warnings, and this is for matplotlib. We know what we're doing here. All right, so these are the necessary imports for this build. We can now build the wrapper for interacting with interactive brokers. So I'm going to create a class for this. I'm going to say class IBApp, and we're going to implement eWrapper and eClient. And this class is then going to be capable of sending requests to interactive brokers via the eClient and receiving the data for those requests via the eWrapper implementations within this class. So I'm going to say def init self callback. In this case, we'll say none. And then I'm going to initialize the eClient. Self and self. That's just saying, hey, superclass, the IBApp is going to be capable of both sending and receiving requests and data, respectively. We're going to have a flag for whether or not we are connected to the server. We are going to keep track of the last price of the instrument that we are tracking. We are going to keep track of the bid price. We are going to keep track of the ask price. We are going to keep track of the historical data for calibrating our Markov chain model. And I will also keep track of whether or not the threading event for querying that historical data is complete, so we can move on to the rest of the program. So I'll call it hisDone. I'll say this is equal to threading.event. And we also need to keep track of the callback when tick data arrives. So I will say self.callback is equal to callback. All right. So that is the constructor for our IBApp class. We now need to handle a few different callback functions from interactive brokers in the eWrapper by implementing them. So what I'm going to do is I'm going to say def error. We're going to start with this guy here. We're going to take a request ID, an error code, an error string, and an advanced order reject JSON. And this is a function that we are implementing in the eWrapper from the eWrapper class. And this is where Interactive Brokers is going to send any errors that we might have in our data request or in some form of response. As you can see, it's going to give us the request ID and the associated error code and an error message. So we're implementing this, and then we can print it to the user. Hey, your request ID 1, 5, 10, whatever it is, has this particular error code, and it's going to print out the error message from the server. So we're going to handle that here. We're going to say if error code is in, here is a set of codes that are non-error messages. They're just connection confirmations or data farm statuses. We're going to say 2104, 2106, 2158, and 2176. If we have any of those, we're just going to return in this callback. We don't need to consider anything. We don't need to report this. This is just confirming connection or data status. If we have an error code of 10167, then we are going to be using delayed market data. So we're just going to make that note. We're going to say note using delayed market data, and this is going to print to the console, not our user interface. And then we will return. Otherwise, if we are pinging this function, that is our server's pinging this function, we have some form of error to report. So I'm just going to print the error as a formatted print statement. I'm going to say error with the request ID, and we will display the request ID. We will also display the error code. Then on a new line, I am going to print the message. All right, and that's going to do it for this error function. So when the server has any issues to report, it's going to report it to this function. And if it's just a blanket confirmation that we've connected, we have appropriate market data farm status, then we're just going to ignore this function call. If we're using delayed market data, then we're just going to make that note to the user. Otherwise, we certainly will have an error, and we're going to print that out to our console. We can also create a logger in the user interface. That could be a nice extension if you're interested in building off of this project, but this will certainly suffice for now. Okay, we are now going to implement the next valid ID function. And within this next valid ID function, we are going to parameterize it with an order ID. This is going to be the next valid order ID that we can use to submit some sort of order to the server, whether we're trying to buy or sell some sort of underlying contract. But the trick here is if we're pinging this function, that means we've connected to the server. We can use the connect acknowledged function from the eWrapper, or we could just use this next valid ID function to note that we are effectively connected. So what I'm going to do here is I'm just going to say self.connected is equal to true. The only way to reach this function is if the server is responding with a valid order ID. So that certainly means that we are connected. I'm just going to say print connected to TWS. We could also use the connect ACK function. It's really dealer's choice here. You could use connect ACK, disconnect ACK. It's entirely up to you. But for the sake of this, since we're not actually dealing with any orders, I'm just going to acknowledge the connection within that callback. All right. So now we need to handle historic data, not just the historic data request to the server, but when the server responds with that data, we need to store it somewhere. Well, when we created this IBApp class, we already created a dictionary to store the data in. So that's exactly where we're going to put it. I'm going to say def historical data self rec ID bar, and the server is going to respond with that bar data that we are then going to store. So if rec ID is not in self.historical data, self.historical_data, that is our dictionary, Then what I'm going to do is create a new list. I'm going to say self.historical data. Within that dictionary, the key that I'm going to use is the rec ID, and I am going to store an empty list. And then within that empty list, I can retrieve this empty list by just calling the dictionary with the key value of the rec ID. I'll say self.historical data rec ID, and then I'm dealing with, this is now a list object. I will say .append, and then here I'm going to append a dictionary of open, high, low, close. I'm going to say O maps to bar.open, H maps to bar.high, L maps to bar.low, and then C maps to bar.close. So anytime a historical data request is fulfilled by the server, it's going to hit this function. It's going to provide a bar of historical data, and we're just going to append it to this list. It's exactly what we're doing here. All right. As you can see, if we create a new request, when we recalibrate, right, we click that recalibrate button, as I demonstrated at the start of this video, then what's going to happen? We're going to have a new market data request for the latest set of historical data, and it's going to be a new request ID. So we'll create a new list, and then we're going to store that new historical data in a brand new list for that new request ID. That is exactly what is going on here. That's how we can ensure that we're not using stale data to calibrate our model. All right, so that's going to do it for this historical data callback function. Then what we're going to do is on historical data end, we are just going to make note to the user here, historical data end, self rec ID, start, and we are just going to call self.histDone, and we are going to set it. All right. So the signal is complete here, and we are all set on receiving the historical data request. That means our model is effectively capable of being calibrated to it, and then we can implement that model directly on live data. All right, so we do need to wait for that historical data request to complete before we can start the stream of live data with the calibrated Markov chain model. All right. So that is going to do it for the historical data callback functions, callback methods. Now we need to handle the tick data for the live data stream. So I'm going to call def tick price, self rec ID, tick type, price, and attribute. And then here I'm just going to say if price is less than or equal to 0, then we are going to return. All right. Clearly, that is not a price that we are working with. We're either dealing with frozen data or we're not receiving market data, whatever a negative or 0 value for price implies. But if we are streaming data correctly, we're going to make it past this return statement here. And we're going to say if tick type is equal to 4, then what does that mean? Well, that's going to be the last traded price. I'll say self.lastPrice is equal to price, and that's going to be the price within this callback. What's going to happen is on the start of the application, when we click that start stream button after we've connected already, then a new market data subscription is going to be created with a request ID. And every single time there is a tick update to the price, it's going to ping this callback method with the request ID and the price and the associated tick type. So here, this is going to be the last traded price if we use tick type of 4. And we can say if self.callback, then we can just say self.callback price, date, time, now. And that is effectively going to be the price and the associated time that we received that tick. All right. So we're going to handle that later on, but for now, let's continue here within the tick price callback method. So what if we have instead a tick type of 1? A tick type of 1 corresponds to the bid price. So I'm going to say self.bid price is equal to then price. A tick type of then 2 corresponds to the ask price. All right. So this is going to update the necessary fields within our IBApp class based on the response from the server. Keep in mind, the price here is a parameter of this callback method. All right. That is the price that the server is going to respond with the associated tick type. All right. So if the tick type is 4, then we know we're dealing with the last traded price. If the tick type is 1, that is going to be the bid price. So that's how we know which to assign the price during that particular call of this method. And then if we wanted to extend this to volume regimes or even social sentiment, momentum, reversion, whatever it may be, then we could use tick size. It would look something like this. If I had def tick size, self rec ID, tick type size, I could get the volume, but I am going to leave that as an extension if you're interested in working off of this implementation. All right. If we have some sort of last trade time as well, then that is going to arrive in the tick string callback. But we're already handling the time using the date time module here. So these are some extensions you can implement if you choose to do so. It is roughly equivalent to implementing connect ACK, disconnect ACK. You can use either methodology. It's not going to impact the function of the application that we are building together. All right. So now that we've built out the IBApp class, we can move on to this open, high, low, close bar class. All right. This is going to represent a candlestick bar. I'll say class open, high, low, close bar. And then I'm going to create a constructor. And within this constructor, I'm going to have a timestamp and an open price. And this is going to be when the bar started. So I'll say self.timestamp is equal to timestamp. Self.open is equal to open price. Self.high is equal to open price. Self.low is equal to open price. Self.close is equal to, again, open price. Because keep in mind, this is going to be the start of the bar. All right, so we're actually creating the bars that the user is going to be observing. All right, so when we initialize a new bar, everything is the same, right? We just are dealing with a tick of data. So the open, high, low, and close are all equivalent. But as things change, then we're going to update that information accordingly. So we define the fields as the default open tick price. And then we are going to set the tick count, in this case, when we create this new bar, to 1. And then the current regime to 0. This is our volatility regime. The Markov chain model is going to produce 0 for low, 1 for mid, and 2 for high. You can specify this however you like, but this is how we're going to do it within this series. All right. Now we need to create a function to update our bar data. We have an open, high, low, and close, and a tick count to update. So I'm going to create a function called def update with a price. And what I'm going to do is I'm going to say self.high is equal to max of the current high and this new price. self.low is equal to the min of the current low and the price. Self.close is going to be equal to the price in any case, right? Because we're going to continue to update this bar until we roll to the next one, right? So in any case, the close, when we update this particular bar, is going to be the latest price that we observe. All right, and then of course we are going to increment the tick count. Okay. The logic here is we only need to update the high if we've seen a new high. That's why we're calling this max function, and the same logic applies with the low. We don't actually have to store an array of that data. We can just continue to make this update to the open, high, low, and close. The open, of course, is not necessary for the display. All right. We're going to create a new property now, and this property is going to be volatility. And in this case, we can use quadratic variation. We could do it as some sort of price range, a percentage of the close price. I'm going to do it just as a percentage of the close price for simplicity's sake. You can define your volatility measure however you would like. You can calibrate a Gaussian, you can use standard deviations, whatever you'd like to do. In this case, I'm just going to say return self.high minus self.low divided by self.close if self.close is greater than 0. Otherwise, we're going to produce a 0 value for volatility. We do not want to divide by 0. All right. So that is going to be the case here. The close is always going to be greater than 0 unless we're not streaming data. In that case, our application would throw an exception. So that is exactly why I am conditioning on a positive close price here. So now that we've built the class to handle our open, high, low, close bar data, we can build the class for our Markov chain regime switching model. This is what we are going to do in the next video, but we're still going to define the functions to be used in this application herein. So I'm going to say class MarkovRegime. I'll create a constructor. I'll just leave it blank for now. I'm going to create a function called calibrate. And this is going to calibrate to historical bars as we've already handled above. Then I'm going to create a class called Gaussian likelihood. And this is for our Bayesian updating of the current regime based on the emission probabilities. And then I will create a function to actually get the regime. All right. So this is going to be implementing a Markov chain model. We're going to calibrate it to historical data. We are going to segment the historical data into different volatilities based on percentiles. This is how I am developing the notion of volatility. You can use whatever measure you would like. There are plenty of measures. You could use even a series of measures and then compress them using some sort of principal component analysis in a linear sense, or you could even do some form of nonlinear dimensionality reduction with some sort of autoencoder. This is Python after all, so you could implement PyTorch very easily to develop that structure. In any case, I have a video on Markov chain models and hidden Markov models that walk you through exactly what they are and why they're useful in practice, and I apply them in two very interesting settings. And the hidden Markov models video actually deals with latent volatility processes. So if you're unfamiliar with those topics, I highly encourage you check those videos out. They are directly applicable to this system that we are building. And if you wanted to make your own extensions using those different types of models, or even alternative regimes, or extending the state space, then you certainly can do so. So this is the Markov regime model class. I'm going to leave it as a blank shell for now. We are going to approach this in the next part of this video. Now we're ready to actually create the main user interface. So I'm going to say class LiveMarketDashboard. And here in the constructor, I'm going to take the root of the application. This is when I call tk.root, I'm effectively just creating the window, and then I need to populate it with everything that I want to see, all my buttons, all my charts, this, that, and the other. So what I'm going to do in this constructor is say self.root is equal to root. Self.root.title is going to be live market data dashboard. Self.root.geometry is going to be 1200 by 800. Self.root.configure. I want a background color to keep this nice dark theme, so I'm going to use 0D1117. And then I am going to continue with this dark theme. I will say self.style is equal to ttk.style. And then self.style.theme use, and we're going to use clam here. And then we'll call self.configure dark theme. And we're going to have to build that function. Okay. So now within this live market data dashboard here, I'm going to create a new interactive brokers app. I'm going to initialize that IBApp class that I created above. I'm going to say self.IBApp is equal to IBApp. And now I can assign a callback. If you recall, above, when I use self.callback, I am indicating a price string, the actual price associated with that tick update, and the associated date time. So that is what we are going to have to implement within this live market dashboard class. So I'm going to call that self.onTickData. And that is going to be the callback of interest. And that is what is going to effectively update the tick data once we receive it from the server. Remember, this tick data is going into the bars that we are displaying to the user in those open, high, low, close candles. We are going to say that we are disconnected by default, so connected is equal to false. Then we will say self.streaming is equal to false by default until we are effectively connected and start streaming data. I'm going to now fix my bar duration. I'm going to say self.bar duration, and you can make this whatever you like depending on the interval that you are trading. I'm just going to make it 5 seconds per open, high, low, close bar. The max bars that I'm going to display is going to be 10 plus the present bar. It's going to be rolling in that queue so we can continue to pop the last item. The open, high, low, close bars will be equal to then DQ. Max length is equal to then self.max bars. So we have this fixed length queue. Self.current bar is going to be equal to none until we actually create it. We've already created the class for these bars, so it's going to be pretty easy to handle and display them on the chart. Then we'll say self.bar start time is equal to none. Again, we're going to handle that when we receive tick data. Self.price history is going to be equal to DQ. And we will set the max length to a default of 100. This is going to be our recent tick prices if we wanted to store them for whatever reason. We can even use this to not necessarily fetch historical data for the latest 60 bars. We could just use this price history queue depending on how far back we want to calibrate the Markov chain model. All right. I'm going to create a last update time and a regime model, which is, of course, our Markov regime class implementation there. Only a few more things. We need to create a bar lock, which is a threading lock to protect the bar from race conditions on updates. We need to create an update thread This is for bar management. It's going to be a background thread, and we're going to set running equal to false. And then we're going to create these functions to help set up the user interface. We'll call it setup UI, and we'll call it setup chart. And that should do it for our LiveMarketDashboard constructor. Let's work on making some of these necessary methods within our class, like the onTickData method, the setup UI, setup chart, even the configure dark theme. So let's just start with the theming, because I think that is going to be the easiest to do. So I'll say configure dark theme. And what I'm going to do is I'm going to set the background color equal to the other color that I was using earlier, 0D1117. This is our main background color. Then we have our foreground color. This is going to be C9D1D9. And then we will have an accent color. This is going to be 238636. And then an entry background color. This is going to be 161B22. All right, very good. Now I'm going to call that style that we created earlier and configure everything. I'm going to say tFrame. We will make the background color. So we're going to configure the tFrame and the tkinter root that we're applying the styling to. So we're going to configure tFrame, tLabel frame. We'll make the background color, the foreground color. Shocking, I know. We will make the label frame. Labels have the correct background color. And of course the correct foreground color. And then we're also going to apply a font. We will make it 10 points and bold. You can use whatever font you'd like that you have installed. So we apply the foreground color, apply the font, apply the background color. We're going to do the same actually for the button and for the label, so we have consistent styling. I'm just going to copy and paste this so I don't have to retype the whole thing. So we did it for the label frame label. We did it for the label frame. Now we're going to do it for the tLabel in general. And we're not going to use bolding for just the arbitrary label. We're just going to have it as 10-point font. And then for the button, we are going to apply 9-point font. And that should look good. I think we also need padding for the button as well. So I'll add padding. 10 and 5. Height and width should be reasonable. Width and height, I should say. Now we need to create a map for the T button. And this is going to be for the active and inactive statuses, the active or disabled. So I'm going to say background is equal to, and then I'm going to create a tuple of active. And then I will set the color to 2EA043. So that is going to be the active state. And then disabled is going to have a color of 21262D. 21262D. Same difference, but fair enough. All right, that is going to be the active and disabled map for the button. Now we need to do the entry for where we actually type the security, the symbol that is for the data that we're going to be streaming. I will say self.style.configure t entry, and then here we're going to say field background is equal to entry background. Foreground is equal to foreground color. And then the insert color will just be the foreground color. And that should do it for our entries. And then we can also add accents as well to the button. So I will say self.configure. And we are going to say accent.tButton, and we will apply a background of DA3633 and a foreground of whites. Okay, and then we're going to create a map for that accent button as well. I'm just going to copy that map from earlier, accent.tButton, and then active I'm going to use instead here. We're going to say F85149, and then I will use the same disabled status there. All right, so that's how we're going to configure this dark theme. That's going to do it for this method. We can now move on to setting up the user interface itself. We've styled all of the widgets that we're going to place within our root. That is, we're going to have buttons, we're going to have label frames, we're going to have that matplotlib figure canvas that we're going to call updates to. We'll have rectangle patches for the candles, but we're going to build those as we get to them. For now, let's continue building this user interface. So we have a place to put all of those items. I'll call it setup UI, self, and then mainFrame is equal to ttk.frame, self.root padding is equal to, and I will say 15, and then mainFrame.grid, I'll say row is equal to 0, column is equal to 0, sticky is equal to n su, so north, south, east, and west, and then self root.column configure, and we're going to have a weight of 1 in the 0th column, and we're going to do the same for the 0th row and the mainFrame's 0th row and or 0th column and 2nd row. So I'll say self.root.row configure 0 weight 1, and then to the mainFrame column configure 0 weight 1, and then mainFrame.row configure 2 weight 1. And that's because the chart row is going to expand, right? We don't necessarily want the entry fields at the top, the local host, the port where we're typing the security, the symbol for the data that we're streaming to expand. We want that chart too. So what we're doing here is we have that root, right, that we are providing to the constructor of this LiveMarketDashboard class. We're assigning that root to the root field, the root variable within this instance of the LiveMarketDashboard, and we're going to put a frame within that root window that we can then add widgets to, label frames, buttons, charts, whatever. And we are just aligning that main frame within that root window. Row 0, column 0, it's going to be sticky to every end of the original frame. That's the north, south, east, and west there. And then we're going to configure the weight of the root application itself and then the weight of the main frame. So keep in mind, right, we have the root window, but that's not where we're placing the widgets. We have the main frame that lives in the root window, and that is exactly where we're placing everything. And the reason why we did a weight of 1 in the 2nd row here is because that is where the chart is going to live. We only have effectively, depending on how you look at it, just one column. So the 0th column will get all of the weight in the root of the application and the main frame. All right. So let's start by creating now each of the sections for connecting, for streaming data, so on and so forth. I'm going to start with this header frame. This is going to be ttk.frame. I'm going to put it within this main frame. The header frame is going to have a grid layout, row 0, column 0, sticky to the east and west, right? This is just the fields. We don't need it expanding north and south. We'll have some padding on the y-axis, 0.15. That should suffice. And now I'm going to be adding some labels to this header frame. All right. So I'm going to have a title label. This is going to be tk.label. We're going to place it within the header frame. I'm going to call this a live regime switching application. And I'm going to assign some font here just to make this look nice. I'll have JetBrains Mono 18. We'll make it bold. And then the background, I will do 0D1117, just as we've been doing before. I probably should have a variable for this globally, but here we are. So 58A6FF, and then that is going to do it for this label. We need to choose how it lives within this header frame. I'm just going to pack it to the left side. All right, now we need a label for the status of the application, whether or not we are connected. I'll say self.status indicator is equal to tk.label header frame. Text is equal to, initially we'll say disconnected. And then I'm going to, of course, assign a font here. I'll use the one that we were using prior, 10-point bold, and then the same background here. Man, I'm really in too deep on this background foreground color, but is what it is. Same background color, and foreground color we're just going to use F85149. Okay, so when we're disconnected, it's going to display in that capacity, that black and red. To stay on theme, we now need to choose where it lives in that header frame. So keep in mind, right, what we're working with here is we have our root, we have our main frame, that's the whole thing here. We're placing now a header frame at the top, and now we're putting widgets within that header frame. We have the label for the live regime switching model, and now we're going to have the label for whether or not we are connected. The live regime switching model was packed to the left. We'll pack this then to the right. And we'll have some padding on the X. All right. So now we need a control panel for everything. Those are just the labels. Now we need to create a frame for the controls. So I'm going to say control frame is equal to ttk.labelFrame. And within this label frame, we're going to place it in the main frame. So this is not the header. This is the label frame for the controls of the application: connect, disconnect, stream, recalibrate, so on and so forth. So that's going to be the control panel. I'll have some padding. We're placing this in row 1, column 0 of that main frame. Remember, we have what? The second row reserved for the chart, the candles. So this control frame lives above it. We're going to say control frame. Dot grid, we're not packing it in there, right? We're going to place it explicitly in row 1. We already have the header frame in row 0, so we'll throw this in row 1. We'll throw it in column 0. There's really only one column. Sticky towards, of course, the east and west. We don't need it to expand like the main frame to the end of the root. We just need it to expand to the left and right. Then we'll have some padding on the Y. And that will do it for the placement of this frame. Now we need to populate it with things. We need to populate it with a host and port, entry, button to connect, everything like that. So I will create a connection section. This will be ttk.frame. We're going to put it in the control frame. And I'm just going to pack this in there. I'm going to say pack. We're going to fill the X space. And I will have some padding on the Y-axis, 0 and 10. Now I'm going to place a label in the connection section. The text will be host. We're going to pack this to the left side and put some padding on the X so that we can put the entry. I want you to notice that I am not creating a variable to store this label. I am initializing this label object and immediately packing it inside the connection section. I cannot access this label if I want to unless I go into the connection frame and somehow retrieve all of the widgets that were stored in it, that are being placed within it. So I don't need to store this label as a variable. I can just pack it directly into my frame. That is what I'm doing there. Unlike the host variable itself, which I do want to access, that's how I'm going to create the connection request to the server for interactive brokers. I'm going to say self.hostVar is equal to tk.stringVar. This is going to keep track of the value in that entry. Our local host is 127.0.0.1. That is the default host. And the host entry is then going to be a tkinter entry. We're going to place it in this connection setting. The text variable that is going to link the entry that, whatever the user types in this host entry to some sort of variable on the back end. In this case, it's going to be the host var is going to store that content. So that is how we connect the entry to a variable to use to create the request. I'll say text variable is equal to self.hostVar. And then the width of this entry, we can just make it 12. It doesn't need to be too large. It's just the host. Now, this host doesn't actually live in the connection section yet because we haven't told it how to live there, how to place it. So I'm going to say host entry, and we're going to pack it to the left side. And we will say padding X 0 and 15. The reason why this works is because we're padding the host label, or we're packing the host label to the left with reasonable padding on the X axis, right? Left and right. And really, we're just throwing padding on the right side there. So then when we pack this entry, we've linked it to this variable host var. So whenever we want to request whatever the user typed in there, we can just access this host var. But the point is, when we pack this host entry, now it's going to be placed beside this label. We pack this to the left, then we pack this to the left. All right, so nothing too complicated there. And then we can actually just do the exact same thing with the port. It's just going to pack the label for the host, the entry for the host, the label for the port, then the entry for the port. So I'm just going to copy all this, and I'm going to put the port pack to the left. Of course, the default port for paper trading is 7497, and then we can pack it there as well. But do keep in mind, we have to change the string variable and the entry. This label is not being stored as a variable. It does not matter. But for the host var, we do need to change this to the port var. This is no longer the host entry. This is the port entry, and we can just place that there. We do need to make sure that we map it to the correct port var as well. So now this is the exact same thing that we had for the host, but now specified for the port living in the connection section. Okay. We're now ready to add connect and disconnect buttons. I'm going to say self.connectButton is equal to ttk.button. We're going to place it in the connection section. The text is going to be connects. The command is going to be self.connectIB. Makes sense to me. We certainly want to connect to interactive brokers if our connection button is clicked. So that is going to be our function to connect to interactive brokers. We're going to have to create that as well. Self.connectButton, we are going to pack it inside this connection section. we're going to place it on the left side as well, and we will also have padding on the right side of the button. So everything is just going to be packed linearly from left to right, all of these different sections. All right, so that's our connect button. Now we could do the same thing for the disconnect button. ttk.button. The connection section is where we're going to place it. The text is going to be disconnect instead of connect. Now the command is going to be self.disconnect IB, which we will also have to create. The state currently is going to be disabled. We cannot disconnect unless we are connected. Style accent.tButton. We've already configured what that looks like. All right, let's add a a visual separator now. I'll say sep is equal to ttk.separator. Place it in the control frame, orient it horizontally. And then we could just fill the X with that separator. Have some padding over and under. 10 should do it. All right. Now we need to create a section to request a live data stream. To do this, I'm going to create a new section. Data section is equal to ttk.frame. We're going to place this in the control frame, of course, but where? We are just going to pack it, filling the x-axis left to right. All right. Now we need inputs for the symbol that we are streaming. So I'm going to say ttk.label. This is going to exist in the data section. The text is going to be symbol. And here I'm going to pack it to the left side. This is exactly what we did above. Throw some padding on the x-axis to the right side of the label. We're not storing it in a variable. We are just adding this symbol label. Now I need a variable to keep track of what was entered, just as I did above with the host and port. Self.symbol var is equal to tk.string var. The value is going to be, in this case, we'll just default to Apple. Now we can create the entry for the symbol. Place it in the data section. The text variable will be that symbol var that we just created. Self.symbol var. The width can be reasonably small as well. And then the font we will default to JetBrains Mono 11. And that will do it for our symbol entry, but we need to tell it where to live. And that is going to be, of course, in the data section, but we are just going to pack it, just as we did above, to the left side. Okay. Cool. Now we need the buttons. I'm going to say self.stream button is equal to ttk.button. We're going to place it in the data section. The text is going to be to start the data stream. The command is going to be self.toggleStream, and we are going to create that as well. The current state is going to be disabled until we are connected. We are just going to pack it in, just like everything else, to the left side. And then that should do it for the streaming. We also need a button to choose to, whenever the user chooses to recalibrate the Markov chain regime switching model. So we'll create that button now, and the function for recalibration we will handle in the next part of this series. So I'll say self.recal button is equal to ttk.button. We're going to put it in this data section here. The text is going to be to recalibrate. And the command is going to be self.recalibrate model. The state will be disabled. We are then going to pack this button to the left, just as the others. Have the same amount of padding on the right side of it. And that should do it for the streaming and the calibration button. So we have the entry for the symbol that we are going to be streaming, whatever contract it is. It could be an equity, it could be a futures, it could be an ETF. It doesn't matter. You can specify the contract however you like. In fact, you can add more toggles for the security type, so on and so forth. If you wanted to, it's a very easy extension. You just add a combo box to this section here, and then when we create the data request, you can just fetch it directly from that combo box. But in any case, that should do it for the interactions here. Now we're going to want to specify the price, and that's going to be the current price streamed from the server. That's the spot price of the asset. We can use last bid or ask however we want to, the last trade price, or whatever the current quotes are. But that's going to be entirely up to you and whatever you'd like to display. So I'm just going to display the last. I'm going to say price frame is equal to ttk.frame. We're going to put this in the data section as well. I'm going to pack it in, and I'm going to place it on the right side. Then I'm going to create a label for this within this price frame, and I'm going to call it the last price. And this last price will have a similar font as we used before. And then I am going to just pack it in to the left side of this price frame. Then I'll have some padding on the right side of this widget. That's the pad X there. All right, now do keep in mind, right, there's a lot of moving pieces here, but we're creating a frame for the data section to place these widgets inside, right? We still have our root, our main frame, which expands to the north, south, east, and west of the application. Then we're creating smaller subframes within it to place widgets there. So within our data section, right, we're placing this price frame to display the last price. Same thing with everything else we've been doing up until this point, right? We have our control frame. That's where the data section lives, and the control frame lives within the, if we go back up here, the control frame lives within the main frame. All right. So now that we have this label indicating our last price, we need a place to display it, right? So I'm going to actually create a variable now for this label that we can access with new data. This is very different because instead of it just being a label that lives within this frame, we can update it by accessing this variable. I'm going to say this is equal to tk.label. I will place it in the price frame. The initial price is just going to be zeroed out. We don't have a price to display. The font is just going to be that JetBrains font that we've been using up until this point. Leave it as 16-point bold font. And let's actually make the background color and the foreground color match as well. We'll use that same background color we've been using, 0D1117. And then for the foreground here, we will use 7EE787. That green styling. All right. And then we need to place it within this price frame. So I'm going to call self.price label.pack. And we will put it on the left. So we will pack it to the left. So keep in mind, this price frame lives on the right, but we're packing the label for last price to the left and this actual label indicating the price to the left. So the label actually lives to the left first, then we place this price label in. That's going to be after it. So it's going to be effectively, I'll mirror it for you watching. It's the last price label. We're packing it to the left, and then the actual price gets packed to the left here. So the label reads from left to right. And then this label here is stored in a variable. That's how we update the price. All right. So now we can move on to the chart itself and the chart frame. So what we're going to do is create a chart frame, and this is going to be equal to ttk.labelFrame. And then we are going to place this within the main frame. We know where this is going to exist, column 0, row 2. That's how we assigned the weights earlier. So the text here is going to be live open, high, low, close with Markov regime. This is going to be 5-second bars as we used earlier. You can use whatever you like. The padding is going to be 10. And then we are going to place this, as I said, grid row 2, column 0, sticky. And we want this to be sticky within this particular grid because this is going to be the chart frame. So as this grows and expands, we want it to grow and expand in every direction. All right. So now I can configure the column, and that is going to have a weight of 1. And I can configure the row, and that is going to have a weight of 1. That's where the container for the figure is going to live effectively. So let's create this container. It is going to be a frame that exists in the chart frame. And of course, we are going to place it in row 0, column 0. Same behavior, north, south, east, and west. Sticky to the north, south, east, and west as we continue to grow the window as it gets resized. Then I will say self.chart container.column configure, and we are just going to assign the same weights as prior. Column configure and row configure. All right, that looks good. So that is where our chart is going to live. Now we could add a frame at the bottom for the statistics that we're observing. That is, how many bars we've queried, how many ticks per the current bar, so on and so forth. So let's do that. I'm going to create a stats frame. This is equal to ttk.frame. We're going to place this in the main frame. Where does this live? This is going to live below that chart frame. So I'm going to say statsFrame.grid row 3, and then column, this is going to be 0, sticky to the east and west, just like our control panel. We don't want it growing to the north and south. Padding Y, we're going to have 10 and 0. So padding on the top in that case. And then we can have a whole bunch of labels. So I'll say self.statsLabels is equal to this dictionary. And then I'm going to populate a list of tuples. I'll have bars 0. I'll have high, and I'll leave it empty. I'll have low, and I'll leave it empty. And then I'll do regime, leave it empty. And then ticks per bar, I will leave it as 0. Then I'm just going to say for I name and value in enumerate, and we're just going to enumerate these stats for the sake of construction. This is going to save us a lot of time instead of just typing everything out. I'm going to say frame is equal to ttk.frame stats frame. Within this stats frame, I'm just going to pack to the left side with some padding on the x-axis so that we can add all of these labels. I'll say ttk.label. And we're going to place this within that frame we just created. The text is going to be what? Well, it's going to be what we are enumerating over. I'll use a formatted string here. And I'm just going to use the name. And that is going to, of course, correspond with a value. So the font here, I will just use the font we've been using all along. I'll use 9 point. I won't bold it. And I'm going to pack this to the left side. Now that we have the correct label, right? I want you to see what we have here, right? We're just enumerating these statistics here, right? So we're just unpacking this list effectively of tuples, and we have the name, so that's going to be bars here. Then we're going to have the corresponding value. All right, so how do we place that value? Well, I'm going to create a label. I'm going to call it tk.label. Place it in the frame. The text is going to be the corresponding value. The font, in this case, we will make it now JetBrains, so it's different than the label. Make it 10. We'll make it bold here for the value. And we will assign a similar background color and foreground color as we've been using all along. .949E. All right, and then we're going to pack it to the left side so it lives right next to its own label. Have some padding to the left of it. And then within the stats labels dictionary, we're going to create a key that is the name of the particular label and its corresponding value, and assign it to the label that we are storing the value in. This is very important here because what we've done now in this LiveMarketDashboard is created a new dictionary for the stats labels, and we are linking the name of the statistic, bars, regime, high, low, ticks, bar, whatever it is. We are using that as the key to this dictionary to retrieve the corresponding label that is presenting the value to the user interface. That's exactly what we're doing here. We don't care about the label itself. We care about the label presenting the value because that's what we have to update. All right. So that is going to then do it, I believe, for this setup UI function, this method. We can now move on to setting up the chart. Let's create this method here for setting up the chart. I'll call it def setup chart, very creative. And I will start by setting the matplotlib style to use a dark background. And then I'm going to establish a figure and an axis. Within this LiveMarketDashboard, I'll say self.fig, self.ax is equal to plt.subplots. The fig size we're going to use is just told by 6. Pretty standard. The face color is going to be a dark color, the one that we've been using all along. And then we're going to do the same thing for the axis, but change the face color ever so slightly for a little bit of contrast, 161B22, keeping that dark theme. All right, so let's go ahead and style the rest of the chart to be in line with this dark theme. I'm going to start with the tick params. I'll set the colors to be, in this case, 8B949E, and we're going to keep that light. And we'll set the label size to be 9, so that's going to give it contrast against the dark background. Now I'm going to do the spines. We'll do the bottom. We'll set the color to 30363D. So it's an off gray. And we're going to do that for the top left and right as well. Okay, and then we're going to do the same for the grids. So everything matches. Grid. We'll make the alpha 0.2 so there's some transparency. We're going to use the same color that we just used for the spines. Oops, I called this P signs. This needs to be spines. All right. The line style, we'll make it dashed. And that should do it for the spines and the grid styling. We can move on to the labels and title now. So we could say self.x.setXLabel. We'll make it time. This is the, again, chart for the candles. We're operating on 5-second bars. We're going to be receiving ticks from the server, and we're going to be just stepping through time in these intervals of 5 seconds. So the color here is going to be 8B949E. That's going to be that off-white color. The font size is going to be 10. And we're going to do this again for the Y label, but instead of time, this is obviously going to be price. And then I'm going to set the actual title of the chart to be waiting for data, and we will update it when we actually receive data. So I'll just make the default color C9D1D9 to keep it off-white. The font size will be 12. The font weight will be bold. Then when we actually have data to update the chart with, after that thread clears, meaning we've retrieved the historical data, we've calibrated our Markov chain model, and then we start updating the chart with live tick data, we can then update the title. All right, now I'm going to create the actual canvas. This is going to be that figure canvas TK ag, and this is where we assign the figure and the chart container. Now within this canvas, we are going to get the TK widget, and we are going to place it in a grid, row 0, column 0, sticky to the north, south, east, and west. All right, so we've told the chart, right? This is our figure canvas. We've told it the figure to display where it should live, and then we get that widget itself from the canvas, right? So we've assigned the canvas to this figure canvas TK ag widget. That's how we display it on our frame. So we get this widget and then we place it in a grid layout within the container. Row 0, column 0, it has the weight that we configured in row 0, column 0, and we want it to be sticky to all sides of that frame so it can grow in any direction as the frame expands or shrinks when we resize it. So now the only thing left to do is to set a tight layout for the figure and to actually draw the canvas. All right, so that should do it for setting up the UI, setting up the chart. We can now move on to the server interactions, that is actually making server requests using the IBApp and the eClient implementation. So first, we need to create a method to create a contract to request data for. So we're going to provide a symbol here based on our UI. We can just input Apple, Nvidia, Google, Amazon, it doesn't matter. We're just going to default to an equity. So what I'm going to do is I'm going to say def create contract, self symbol, and then I'm going to create a new instance of this contract class that we imported above. And I'm going to assign a symbol based on whatever we provide to this method. And then I'm going to set the default security type to stock. I'm going to set the default exchange to smart and the default currency to US dollars. And then I'm going to return the contract. Now, if you wanted to integrate other security types, you certainly could. You could add a combo box to where we set up our UI. As you can see right about here, we have our symbol, and this is where the user is going to enter into this entry, Apple, Nvidia, Google, whatever equity they want to stream pricing information for. But you could also just add a combo box for security type, options, futures, so on and so forth, and then fill out the remaining required parameters for the contract to query the appropriate data. And then you could build this regime switching model for not just an equity, then it could be for any security that you would like. So that's a nice extension if you're interested in building off of this project. But in any case, we're just going to assume that we're trying to stream equity pricing information. So we will stick with a stock for the security type. Of course, if you wanted to stream something else, you would add it here as well, right? You would have security type, and then you would provide it as an argument here. But that's not what we're working with. We're going to assume just equity pricing information is what we're looking to stream. We've created our contract now using that method. We can now create our method to connect to interactive brokers. We are going to try to get the host information from our host var. Remember, this host var is stored in our LiveMarketDashboard class. That is directly linked to our entry. Same with the port var. So we're going to get the host that the user enters. We are going to get the port, but if we're trying to connect to interactive brokers, we can provide the host as a string. The port has to be an integer. So I'm going to cast this to an integer. I'm going to create a new function to target using threading. I'm going to try to run self.ibapp.connect to the host and port. The client ID that I'm going to use is 1. You can make this your master client ID of 0, 5, 3, whatever you set in your interactive broker settings. It's entirely up to you. I'm just going to use client ID 1 here. If you have multiple applications running, this can be particularly useful. But in any case, I will then call self.ibapp.run. I will accept an exception as E and then print the error that has been thrown as a connection error. If you're wondering why this isn't occurring in the callback function that we created here, it's because this error is not server side, it's client side. We're trying to initialize a connection. So before the server can respond with any errors from a request we make, we need to connect to it. So here, if we have an error in our connection thread, we haven't actually accessed the server yet, so it can't respond to that error method that we implemented above from the e-wrapper. So if we actually have an error on the client side here, we're just going to print it as an exception. All right. Now I need to target this connect thread. I'm going to say thread is equal to threading.thread. Target is equal to the connect thread. Implement pass through true. Thread.start. For I underscore whatever in range 50. If self.ibapp.connected. We will break this loop, otherwise we will sleep for 0.1 seconds. All right. So what's going to happen here is we're going to run this thread and we are going to target this connect thread function. We're going to try to connect to the server. We're going to wait within this loop. And if the server responds with a successful connection, what's going to happen? Well, it's going to ping our callback method for next valid ID. It's going to set connected equal to true. And because we implement the IBApp within our LiveMarketDashboard, we can look for self.ibapp.connected. So if it is connected, that means the server triggered that flag. and we can break out of this loop. All right. Assuming that we've connected successfully, we can set the connected flag within the live market dashboard to be true. We can then disable the connect button. We can enable the disconnect button. We can enable the stream pricing data button. And we can set the status indicator to connected. And of course, I'm going to want to change the foreground color to indicate that we are connected to green. If even after we've waited for that thread to attempt a connection, we are not connected, then I need to create a message box for the user to see. There is an error, and that error is that we have failed to connect to TWS or the gateway, failed to connect to interactive brokers. We also need to accept any general errors that we may have when initializing this thread to connect. That's exactly what we're doing here. We have this try statement, and if we have any errors there, we are going to show a message box with an error. That is a connection error, and we will print it to the console. This is the exact same thing we did here, but this may not be where the exception is thrown. It could be here, it could be here, it could be here, so on and so forth. So we will handle that general case there. But we will print, or not print it, we're going to show it as a message box to the user what the actual connection error was. We can now create the method to disconnect. So I'll say def disconnect IB. This is much easier. If we are streaming data, then we are going to stop the stream, which is another method that we're going to create. Otherwise, we will just call self.IBApp. We'll access the eClient, and we will say disconnect, and then we will set connected to be false. There is a cleaner way to do this where we could use the connect ACK and the disconnect ACK, but for what we're trying to do here, this will certainly suffice. If we did use the connect ACK, disconnect ACK, then that's where we would set the flags for the live market dashboard. What we would do is we would access the flag from the IBApp and then assign the value here to whatever the IBApp is persisting, because that would be the most consistent with the server. But again, this is just really visual at this point here, since we're operating in the live market dashboard. In any case, once we have set the connected flag to false, we can then reconfigure the button states. So we're going to want to re-enable the connect button, and then we're going to want to disable the disconnect button. We're going to do the same for the stream button. We're going to do the same for the status indicator button. And then we are going to accept a general exception as E, and then print that we have some form of a disconnect error. Okay. Let's create a method now to toggle the streaming of the live data. I'll say def toggle stream. And I'll say if not self.streaming, then we are going to say self.startStream. Else self.stopStream. This is the stream of live pricing data. Now we need to create the method to actually start and stop the stream. If we are not connected, then we can't stream anything. So I'm just going to return. Otherwise, let's get the symbol that the user entered. So we'll do self.symbolVar. That's what's tracking the entry. .get to uppercase. So we get the string. If they entered it lowercase or mixed, at least we'll force it to uppercase, store it in this new symbol variable. If there's nothing, if the user enters a blank entry, then we are going to show them a message. Hey, you have to enter a symbol. And we will break out of this start stream method. Okay, now we're going to use the bar lock to clear the open, high, low, close bars. We are going to set the current bar to none. We're going to set the start time of the current bar to none. We are going to clear the price history. And we are going to create a brand new MarkovRegime model. So we're going to reinitialize that object. We can now create the contract to stream data for because we have the symbol. We're just going to call self.createContract, pass the symbol that we just retrieved from the symbol var. That's exactly what we did here. Whatever the user enters, we're going to get it, set it to uppercase, throw it in this create contract method, store it as a contract here. Now we can create a market data request to interactive brokers. We're going to create two requests. We're going to request historical data to calibrate our Markov chain model. Then we're going to create a live data request. Self.IBApp.historical data.clear. Start by clearing the historical data that we have, if there is any, because we can always start or stop the stream at any time. So we're effectively just resetting our data structures here. We'll do the same with the hist done, tracking the historical data thread. So hist done.clear. Now we're going to request historical data. All right, we are going to specify the contract, which we've already done. We're going to look for 300 seconds. We are going to look for 5-second bars. We're going to be looking for trades. And then we are going to be looking for using the formatted date, false, keep up to date, false. We're going to be setting chart options to an empty list. That should be everything. So effectively here we're showing trades. We're showing the bar size settings here. We're showing the duration of the historical data request. Our end date time is arbitrary because we're requesting back this duration of 300 seconds over 5-second bars. And that should do it. 2 is going to be the request ID for this historical data. So when the server responds back to our client in the historical data request, what is going to happen? It's going to ping this historical data function with a request ID of 2. And it's going to provide the bars, the 5-second bars going back 300 seconds. And we're going to append them then to this list that stores the data with the key of the request ID, which in this case is 2. So that's exactly what's happening there. All right. The rest of these are just arbitrary parameters. You can switch these based on the type of historical data that you are looking for, whatever that may be. In this case, we're just looking for the trades over this interval, and you can calibrate your Markov chain model however you like. I'm just choosing to use 5-second bars, but if your strategy demands a different time interval, then you can look back however long you want. If you're trying to run this on some form of a back test, you could just calibrate the parameters to whatever interval you like. So, this is just for the sake of this example here. We're going to use 300 seconds of historical data, 5-second intervals. That's going to correspond to 60 bars. All right. So now we have to calibrate. We have to calibrate the Markov chain regime model. I'm going to say if self.ibapp.histData.wait timeout is equal to 10, and 2 is in self.ibapp.historicalData. What does that mean? Historical data. Then that means we have successfully retrieved our historical data. So our request was fulfilled because we have the request ID 2 as a key within our historical data dictionary. So that means I can say self.regimeModel.calibrate. Remember, we still have to create this function in the next part of this series, but I'm going to call calibrate on this historical data. So I'm just going to get this historical data from the dictionary using that request ID of 2. And then I can print that we have what? Calibrated a regime model with, and then we can say the length of the historical data that we have in our dictionary. Cool. So we still need to build this calibrate method within the MarkovRegime class. All right, now we can move on to requesting the live market data. So I'm going to say self.ibapp.recMarketData. We are going to use a request ID of 1 here. This is for the live data. We're going to use the contract. We are going to just set the generic tick list to an empty string. We want to fetch everything from the contract. We will set a snapshot to false, regulatory snapshot to false, and we will leave the market data options as an empty list. We are looking for all of those trades, the last prices, the bid, and the ask. I'm going to set streaming equal to true. I'm going to set running equal to true because at this point, if we've made it this far, we've made our requests and we are actively streaming data. We are actively running the application. We've calibrated the model. Now we are going to have to configure the stream button because we want to update the text to say stop stream. And the style here is going to be the accent of the T button as we configured earlier. We also want to configure the recalibrate button because we have now calibrated the Markov chain model to historic data at whatever spot information is available to us over the last 300 seconds. If we wanted to recalibrate over that interval, then we could if we click this button, but we have to enable it. It was disabled by default. So now we enable the recalibrate button and we will update the status indicator to say that we are actively streaming data. And we're streaming it for this symbol. I'll change the foreground color for the sake of readability. Keep it a nice blue. And now we can start a background thread for bar time management. So I'm going to create this update thread here. I'm going to say this is equal to threading.thread. The target is going to be self.barManager. This is going to be a loop that we create. We're going to enable pass-through here, and then we're going to start this thread to continue to run that bar manager. We also need to update the chart, so I'm going to call this chart update loop method here that we also need to create. So that is effectively everything we do in the stream. We create our historical data requests, we calibrate our Markov chain model, we then create a live market data request, we enable the flags for streaming, running, we create our thread to update everything, we call the method to update our chart. And now we're ready to progress to the rest of these methods to ensure the functionality. We of course need to manage the stream. If we choose to stop it, we are going to set running to false. We're going to set streaming to false. And we are going to try to cancel the market data subscription. What request ID is it? Well, the live market data request is 1. So we're going to cancel that request. And if we have an exception where when we try to cancel the market data request, I'm just going to accept a general exception and print it. All right, in the case that we accidentally disconnect from the server and we try to click the stop stream button, in this case, we may have some form of an error. So we're going to just catch it and then print it to the console. Okay. Now we also need to turn off the buttons, right? So after we have stopped the stream, we cancel the stream, we need to update the states. So the stream button can be toggled again to start the stream. The style is going to go back to a T button. The recalibrate button we are going to disable because we don't have any data coming in, so we can't calibrate it to the spot data that we're observing. The status indicator is going to go back to connected. And we will change that foreground color back to green. All right. Of course, we need that method to recalibrate the model, but this is what we are going to work on in the next part of this series, that Markov chain model. All right. Now we need to manage what we do on a tick of data. We have the data type, the value, and the timestamp. This is the callback method that we assigned in the constructor of our IBApp class. Callback is going to be, if we go back to our dashboard, this onTickData method. And if you recall, what did we do within the tick price? Well, we used this method. We provided a price, the actual value based on the tick type, which is just the last trade price, and then we gave it the current time of that tick. So now we're going to build this out here to actually update the UI. If data type is equal to price, which is the only case where we actually call this method anyway, but if this is the case and the value is greater than 0, we don't actually have control over that latter portion. If we're receiving stale quotes, or maybe there's some sort of error in our stream, it may be 0 or less than 0. So we're going to check to see if this value is in fact positive. Then we're going to use our bar lock again. And we are going to store the tick in the price history. So I'm going to access the price history list. I'm going to append the timestamp and the value. And if the current bar is none, then what I'm going to do is I'm going to set the current bar to a new open, high, low, close bar for this timestamp and value. I'm going to set the bar start time to the timestamp. Otherwise, what do I do? Well, I don't need to create a new bar. Remember, this is actually what we're doing in the chart with the queue. We have these open, high, low, close bars, and every 5 seconds we're rolling to another bar. If the current bar is none, we need to create one. If the current bar exists, what do? we update it with this pricing information, with this new tick information. I call self.currentBar.update and I give it this new value. We've already created this. Right? Right here. We update with the current value on that tick. We will update the high if it's a new high, update the low if it's a new low. Otherwise, we will set it to the close and increment the tick count. All right. So that is how we will handle the bar lock. Otherwise, we are just going to update the label with this pricing information. So I'm going to say root.after 0 lambda self.price label.config. Text is equal to formatted string, and we're just going to use a value rounded to 2 decimal places for our price. That's the pricing label. If you recall, that's why we stored it as a variable when we set up the UI right here. We have that label that we didn't store in a variable indicating the last price. Now we have this variable that we can update with the new pricing information as ticks come in. All right, so that should do it for the onTickData method. We can now move to create the method for the bar manager. This is going to be that loop, bar manager loop. And what we're going to do is we're going to say while self.running, time.sleep is 0.1. We're going to check every 100 milliseconds to look for a bar lock. And we're going to say if self.currentBar is not none and self.bar start time is not none, then we're clearly dealing with a bar, right? So we're going to look for the elapsed time as elapsed being equivalent to datetime.now minus self.bar start time. And we're going to look at the total seconds. That is the time elapsed. And this is how we're going to dictate whether or not to roll forward to a new bar. So if the elapsed time is greater than or equal to the self.bar duration, what does that mean? Well, we need to create a new bar. So I'm going to say self.open high low close bars.append self.currentBar. This is quite literally the candle object that we created earlier. We're just going to append it to the list, right? This is effectively our queue. And we are going to create then a new bar. But of course, we need to get the regime from our Markov chain model. So after we roll to the next bar, I'm going to use the regime model to get the regime. And we are going to give it a list of the open, high, low, close bars to determine the current regime as we roll into the next bar. We have not built this out yet. We are going to build this out in the next part of this series. We are now going to set the last price equal to the current bar close, and then we are going to roll it forward. So I'm going to say self.currentBar is equal to the open high low close bar of date time now and the last price. And then I'm going to set the bar start time to the current time. All right, and that is how we are going to effectively just manage all of our bars. So what we're doing here is, again, we are just checking for the time elapsed within the current bar. If we're greater than or equal to the current bar duration, then we're going to append the current bar to this queue of open, high, low, close bars. This is a fixed size. We're going to calibrate to the current regime, or not calibrate, rather, we're going to use the Markov chain model to get the current regime. And then we're going to set the last price to the current bar's close. We're going to set the current bar to a brand new open, high, low, close bar. And that's where we're going to populate it with the current time and the last trade price. And then we are just going to set the bar start time now to the current time. And then we just repeat this again and again and again to continue to roll the chart forward. So that is our bar manager loop. Now we need to update the chart. So I will say def update chart loop. What we're going to do here is we're going to check to see if we are running. So if we're not running, we're just going to return, right? We can't really do anything if we're not running. Otherwise, we are going to draw the open, high, low, close chart. We are going to update the stats. And then we are going to schedule an update in the next 200 milliseconds and save the idea for cleanup, or save the ID for cleanup on close. So I'm going to say self.root.after 200 self.update chart loop. All right. So that's how we're going to update the chart. Now we need to create these methods here to draw the open, high, low, close chart and update the statistics on the bottom for our application. So I'm going to say def draw open, high, low, close chart self.ax.clear with self.bar lock. Bars is equal to list self.open, high, low, close bars. Current is equal to self.current bar. Remember, we've already updated this in our bar manager loop. If the current is not none, that means the current bar is not none. It's assigned to an open, high, low, close bar object. Then bars is equal to bars plus current. We are going to add effectively that list of open, high, low, close bars to paint. If not bars, then we are just going to set the styling of the face to be 161B22. So we're going to have that dark styling. We're going to set the title to be waiting for data. Effectively, we have no bar data in our queue. I'll set the font size to 12, the font weight to bold. The grid I'll leave as the same styling as before. And I will use an off gray and some dashes for the grid. Again, keeping that same styling. So if we don't have any bars, we'll keep that dark mode styling, set the chart title to waiting for data. We have no data to display. Otherwise, we can calculate the prices and we can enumerate through the bars to draw the actual candles on the screen. So I'll say all prices is equal to bar.low for bar in bars plus bar.high for bar in bars. And the price min and the price max is just going to be the min of all the prices and the max of all the prices. The price range will just be the price max minus the price min. And we'll have some padding based on the price range. We'll multiply it by 10% and leave it as 0.01. So the price range times 10% versus 0.01 will dictate the padding. And then Y min, Y max is just going to be the price min minus the padding and the price max plus the padding. All right, that is going to help us scale the y-axis so we can actually see the candles appropriately. That is effectively what we're using this price range for. We're getting all of the open, high, low, close bars. We're looking at the price max and the price min across that range of bars. Remember, we're going to have 50 seconds of data here. 5-second bars, 10 bars in total being displayed, plus the spot bar. we're going to create padding based on the price range that we find here. It's going to be the max between 10% of the price range and 0.01. And that's going to help if we have, maybe just no volume whatsoever, no price movement, then, we can just stick with this smaller padding here for the y-axis. Then we can set the y min and the y max based to the price min less this padding, price max plus the padding. Okay. Cool. And now we're going to assign the current regime to the chart. This is what we're going to paint on top of the chart. And if you had some sort of trading strategy, this is where you could get the regime and pass it to that module as well. So we're going to say if current is not none, that means we actually have bar data. This is where we are going to get the regime's current state. We're going to do this in the next part. Cool. So now I'm going to set the width of the bars to be 0.6. And I'm actually going to enumerate through all of the bars and draw them on top of the figure. So I'm going to say for I and bar in enumerate bars, we are going to create a rectangle. This rectangle is going to be the background for the specific candle at an index. So what I mean is each candle is going to have that background, and that background is going to be the color of the current volatility regime. That is exactly what we are creating here. So I'm going to start with the XY position for this bar's background. I'm going to set that equal to I minus 0.5, so it is centered, and I am going to put it at the Y min so that we span the entire portion of the chart. Then I am going to set the width of the bar to be 1. And as you can see here, the candle is going to then reside within it because I'm setting the width of the candle to be 0.6. Then I'm going to set the height to the Y max less the Y min. And that is exactly why we are placing it at the Y min. It's going to then span the entire chart. I will set the face color to be fully transparent. And we will update this with the current regime based on our Markov chain in the next part of this series. The edge color is going to be none. We will set alpha equal to 0. We'll make it completely transparent for now. And we are going to set the Z order to 0. That is to ensure that this is the background. Then we are going to add this as a patch to the axis, self.axis.add patch, this background. And remember, we're doing this for each bar. So we're going to do this effectively 11 times, 10 for the bars that we're storing, 11 for the spot bar. Let's create a color and an edge color for our candles. We will do 3FB950 for the inner part of the green candle. We will do 7EE787 for the outer part. If bar.close is greater than or equal to bar.open. Otherwise, we are going to create a red candle. That is going to be F85149, and the outline color will then be FF7B72. We will create the body bottom and the body height. That is going to be the min of the bar open and bar close, and the max of the absolute difference of the bar close and the bar open, and 0.001. So we want it to have some mass, right? So if the difference is 0, we're going to set the body height to be 0.001. And we are going to set the bottom to be the min of the open and close, whatever is smaller. All right. Now we can actually draw the candlestick. I'll say rect is equal to rectangle. I'm going to use similar logic as before, but now I'm dealing with the actual candle itself, not the background dictating the regime. I'll do I minus width over 2, and I'll use the body bottom. That is going to be effectively the open or the close, the smallest price. That's the starting point of this rectangle on the Y axis for our candle. The width I decided above is 0.6, so that way it sits inside of the regime. I will give it the appropriate body height, which I calculated here is the absolute difference between the close and the open. And it's going to be the max between that and 0, so there is some max to allocate. Then I'm going to set the face color equal to the color that we decided above, based on whether or not it opened higher or lower. It's going to be green or red. The edge color, we're going to do the same. The line width, I'm going to set to 1.5. I'll have some transparency. It'll make it look a little nicer. And I'll set the Z order to 2, so it sits on top of the regime. Whoops, got to scroll down. Alpha of 0.9, Z order of 2. So that way it sits on top of the regime rectangle. All right. Now keep in mind, we're enumerating, right? So I is going to be enumerating with each of the bars. So that's why we're placing them in the correct locations. If you're wondering why this works, that's precisely why. We are centering the background at each tick, and that's what we're doing here with this difference. And we're doing the same with the rectangle. That's why I'm dividing the width by 2, so it's even within the tick. Okay? So now that I've done that, I have to add it as a patch to the chart. So I'll do self.ax.addPatch. I'll add that rectangle, and we're going to do this 11 times, right? This is a loop, right? That's exactly what we're doing here. For all of the candles, I'm now going to draw the lower and the upper wick. So I'm just going to call self.ax.plot, and I'm going to use the current index and the bar low and the body bottom. And I'm going to use the edge color here, set the line width to be 1.5 and the Z order to be 1. This way I draw the wick underneath the body of the candle. And I'm going to do that for both the lower wick here. I can just paste this again. And instead of the low, I'm going to then, instead of the low and the body bottom, I'm going to use the bar high, and I'm going to use the body bottom plus the body height. So I am placing the wick in the correct location, and that should do it for the wicks. So that's going to be the lower wick and the upper wick respectively. Bar.low, the body bottom plus body height, bar height. Yes, that's correct. Cool. So now we're going to highlight the current forming bar with a vertical dotted line, so we know what the spot candle is. This is just going to be a nice touch. So I'm going to say if I is equal to length of bars minus 1 and current is not none, then self.ax.v, I think it's ax_v line, x is equal to 1, color is equal to, and I will say 58A, 6FF, alpha is equal to 0.3, line style is equal to, we can just use a colon for those dots, line width we will set to 2. So we will have a vertical line at the spot bar. Now I can configure the axis face color. Self.ax.set face color 161B22, nothing we haven't seen before for our dark theme. And now I'm going to set the x-axis labels to the bar timestamps. So I'll say x labels is equal to bar.timestamp dot We're going to format the string time here to hours, minutes, seconds for all of the bars in the bars queue. Cool. And then we're going to set the xticks to be the range of the bars. So it's going to be the range of the length of the bars. So starting at 0, going out to the length of the bars. That's cool. Then we can actually set them. So set the xtick labels to be these timestamps. And we're going to have some rotation so they look nice. We'll make it 45 degrees. And we will set it to the right. And we will make the font size 8. So that'll do it for the timing. And now we're going to do the price range on the y-axis. Self.ax.set ylim to be ymin, ymax. Self.ax.set xlim to be minus 0.5 to the max of the max bars, less 0.5, and the length of the bars, minus 0.5. And the reason why we're doing this is because the bars populate left to right dynamically. So, you know, at some point we're going to have all of the bars being shown on the chart, and that max statement is going to be irrelevant. But as we're building it, we're going to need to use the dynamic length of the bars in the queue. And then the ylim here is just going to dictate the current price range, ymin to ymax. That's really nothing special. So now I think we should format the y-axis to have 3 decimal places. So I'll say self.ax.y-axis.set major formatter, plt.func formatter, lambda x underscore. We're going to format the string x to have 3 decimal places. All right. So that'll be, I think, useful, especially when there's like no trading volume, to still see what's going on. And that's part of the reason why we used the max between the difference and 0.001 here, so that we actually have some mass to visualize on the candles. And now we can just apply styling to the axis itself, the spines. It should work from earlier. We will find out, but we already set it here. So I don't think we need to set it again. Oh, we cleared it though. Maybe the parameters will stay. We'll see. If not, we're just going to copy and paste this, but we'll see when we test it. So I'll just make note of that. May need to reapply styling. Otherwise, we can just set the X label to be time. The color we can set to be 8B949E. That's that off-white, size 10. And I'll just do the same thing here for the Y label. But instead of time, it will be price. All right. Now we need to update the regime, the current regime that's being displayed. So I'm going to say symbol is equal to self.symbolvar.get.upper. And the regime names, in this case, I'm just going to do a low, mid, and a high volatility regime. You can extend this to whatever you want, however you want to classify them, but we're going to build this again in the next part of this series here. For now, we're just going to, for each regime name, we are going to get the current bar regime, and if the bars exists, otherwise we are going to populate with an NA. So we're just going to check to see if we've classified a regime. If not, we'll just put NA, and we can update then the chart with this regime. So we have the symbol, we have the regime, which is the current regime. We then have the length of the bars over however many bars we have. The color for this title, we will make C9D1D9. The font size is going to be 12. The font weight can be bold. All right, and now all we have to do is set the figure to have a tight layout and draw the idle. Wonderful. We can now update our statistics with the new bar information, given we are now running the bar loop. So I can say def update stats self with self.bar lock. Bars equals list self.open high low close bars. Current is equal to self.current bar. If the current bar exists, then bars is equal to bars plus the current bar. If not, then we will just return. There is nothing to update in terms of the bar statistics. And now we can just update all of the labels. Self.stats.labels, or it's really, I think it's underscore labels for the bars. We are going to configure that to have a text of the current length of the bars. Cool. We can look at all of the highs as the bar.highs for B in bars. We can look at the lows as the lows for bars in bars. This is just going to be a list of all of the highs and lows in our 5-second bars. Remember, that's just the queue for our, that's just going to be our queue for the bar data. We can then update the labels. So I'll update high with the text for the current max, which is just going to be the max of all of the highs. And we're going to do the same for the lows. But of course, it'll be the min. All right. We can update the regime in the statistics as well. Regime names is equal to low, mid, and high volatility. The regime colors, blue, yellow, and red. The current regime we can just get from the current bar. If bars is non-empty, otherwise we'll just make it 0. Then we can update the regime label by configuring it. The text will equal the regime names given the current regime. And the foreground color is going to be the regime color of the current regime. So we're using the current regime. It's going to be what, 0, 1, or 2. And we are going to get the regime name and the regime color accordingly. We're going to default otherwise to 0. Maybe we use -1 if we don't want to default to a low vol regime, but I'll just leave it as 0 for now. All right. And if we do have current bar information, then we can get the ticks for this bar. So we can say the ticks per bar, config the text to be the current tick count casted to a string, and then store it in that text. And that's going to do it for the update stats method. So now we just have to handle closing, and then the main load function, and we'll be ready to test this application. On application end, we will have this method effectively ensure a clean close. So we will say def on closing self.running is equal to false. If we have the attribute after ID, then we will say self.root.after cancel self.after ID. And if we are connected, self.connected try if we are still streaming data to cancel the market data subscription and then disconnect from the server. And if we have any form of exception, we will just print it to the console. All right, and then we will destroy the root of the application, and that will do it for our clean close. So effectively what we're doing here is we're just canceling the scheduled chart updates to prevent any errors that we might have as we're trying to shut down the application here. And then here we're just going to try to cancel that data subscription and disconnect cleanly from the server. If we have any issues there sending those requests off, then it will be printed to the console. And then of course we will just destroy the user interface, that root window there. All right, so that's going to do it for this LiveMarketDashboard class. We can now move to the main application entry point. We will say def main, and I'm going to create a new root for the tkinter window. And I will provide that then to the constructor of the LiveMarketDashboard. And I will establish a protocol for this root. On window close, we are going to call that function, call that method on closing within the application on that root window. And then we'll execute root.main loop. And if name is equal to main, we will then execute that main load function. And we're now ready to test our application. As I've gone back over the code, I've acknowledged a few errors that we can very easily correct. The first is if we go to line roughly 131, I have this threading lock. This should be a capital L. If we check out the disabled button or the disconnect button, I did not pack this button to the left side, so it will not be visible. So I will say self.disconnect button.pack side to the left. The connection flag in the LiveMarketDashboard also needs to be updated correctly. If we go down to where we actually connect to the server via the IBApp itself, I have self.connect equal to true. This should be connected is equal to true. Where I set the axis face color, it should be set face color, not set face. And I believe this color code is too long, which is why we're not seeing an example color here. This should be off-white, so C9, D1, D9. Then we will have effectively that off-white that we are looking for. Again, instead of face, I should have face color here in our rectangle for the background for the regime. In this case, it's just going to be transparent, but this is where we would update the regime color. And the same with the edge color in the actual candle bar itself. It should just be edge color. The underscore is for the color that we assigned above based on if we opened up higher from the previous close. And the rotation of the X ticks is spelt wrong here. This should be rotation. All right. And then I believe that should do it. We can give this guy a run here. And we get our live regime switching dashboard here. I could add some padding to the right of the entry symbol if I would like to as well. I can go over to the symbol entry where I pack it. I'll add some similar padding to the stream button, for example. Give this a run again. Added a little bit of padding on that right side now. I can connect. There we go. So it's connected. I can disconnect. All right, it changed the color, but it didn't change to disconnected. If we scroll on down to where we disconnect, the status indicator should change the text to disconnected. That should be correct there. We can also change the color to maybe a red instead. And this would be disconnected. All right, looks good. Connect, disconnect, there we go. Connect, start the stream. Now if we start the data stream, we should observe prices. Well, first we're gonna actually pull the historical data, and then we're going to stream the prices. It looks like we're having an error with the X limit. It should be, because we're querying the tick price correctly, we just need to set the X limit. This should be set underscore X limit. Set underscore X limit. This is where we draw the open, high, low, close chart itself. Give this another run. All right, connect, disconnect, connect, start stream. Query the historical data. Start to try to stream the tick data to bars. And it looks good. We are after market hours right now, but we are effectively streaming 5-second bars. We have 1 tick per bar. The open, high, low, close is just going to be the same as the tick price. And that is going to be the shell for our live regime switching model. That's going to do it for this first part in a 2-part series of building a live Markov chain regime switching model. I hope you enjoyed this first part. I hope you learned something. This video certainly took a tremendous effort to put together, so if you'd like to help support the channel so I can continue to make quant builds just like this one, please like, comment, subscribe, share. It helps me out tremendously. It is always greatly appreciated. If you'd like to master your quantitative skills, learn how to code projects like this from scratch, all of the necessary Python, check out quantguild.com. Other than that, I want to thank you so much for watching, and I will see you in the next video.